So without further ado, AY, are you there? Let us hear your voice.
Yeah, thank you, Gbenga. Good morning, good afternoon, good evening, everyone. Thanks for that wonderful introduction, my guy.
You're welcome.
Screen.
Are you, AY, are you ready for us today?
Yes, I am. I'm trying to share my screen.
Okay.
Can you all see my screen?
Yes. No, okay, yes, we can see your screen now. Over
All
to
right.
you now.
All right, thank you so much. So today for this data track, I'll be talking and walking us through deploying and configuring servers, instances, and databases for Azure SQL. Okay, let's proceed. So getting started, like the moderator rightly introduced, my name is Ayobami Adeleke. I'm a BI developer. I'm also a Microsoft certified trainer. Experience-wise, I've been working as a data warehouse and BI consultant for about 4 years now, and 2 years experience as a Microsoft certified trainer. So I've trained people around the Microsoft data platform, implementing data warehouses, doing BI analytics and reporting solutions and the likes. A few of my certifications are Microsoft Data Analyst certified. I'm also a Microsoft Azure Data Engineer certified personnel. I also have my MCSA in BI development and the Microsoft certified trainer. So you can reach out to me on LinkedIn. Just search for Ayobami Adeleke, you'll see me there. Right. So quickly, my agenda today is quite simple. I'll just walk us through an introduction to Azure Data Services. Take us through Azure SQL IaaS and PaaS offerings as the infrastructure as a service and platform as a service offerings. I will walk us through planning and deployment of data solutions on Azure, and just walk us through a quick demo on the Azure portal. So let's proceed. Introduction to Azure Data Services. Yeah. So the Azure Data Services spans across SQL Server in a virtual machine, Azure SQL Database on the cloud, the Cosmos DB, which is a database cloud platform for unstructured data, table storage and blob storages. So quick illustration around these offerings. For the SQL Server in a VM, that's a virtual machine, and the SQL Server database on Azure, these are fully featured relational database management systems. So an RDBMS system is just a system or solution that allows you to create relational objects, such as a table structure within a database where you have rows and columns. Those are two, the server, SQL Server in a VM and the cloud Azure DB allows you to do full functionalities around RDMS operations. You can create database objects, you can load in data, you can do a lot of database querying, scripting, and analysis and reporting. Also, it allows for transactional processing. So transactional processing is more like your online OLTP architecture, whereby back end of your core business applications are receiving data as transactions are happening on the interface or on the application at the front end. So as people log in, probably like an example now could be a solution, maybe an HR solution that has been built in-house. As people try to fill in records of staff or maybe sales orders and all of that into that application, into the backend is a SQL Server VM, whereby you have a database instance running and you're able to, as the transactions are happening, you are logging these transactions into the database. So it works seamlessly on the VM and the Azure database on cloud, which is the platform as a service. Also, looking at the Cosmos DB, it allows for rich query performance and operations. So you're able to really do some interesting analysis around the data you have within any of the spectrum, either within the SQL Server instance in a VM or the Azure SQL DB or even the Cosmos DB. Now, looking at it from the other angle now, looking at it as a managed service, we can see that managed service cuts across the SQL database on the cloud. It cuts across the Cosmos DB. It cuts across the tables storage and the blob storages. Also, these architectures are quite elastic, so you can actually scale them up. You don't necessarily have to pay for high compute at the beginning. As your business grows, you can increase the settings. It's just for you to go back to the configuration portal on Azure and change the setting. You can scale it up or scale it down depending on your usage. And this also helps you to also these data services are schema-free data. They have a structure that's from the Cosmos DB now. The SQL database is schema oriented because it works relatively like the RDBMS structure. So you can see that the batch starts from the Cosmos DB to the blob storage. So for those three, the Cosmos DB, the table storage, and the blob, they don't have a defined data model or structure. So they are actually suitable for unstructured data. At the same time, they allow internet accessibility, either using HTTP protocols or REST APIs. So you're able to query data from any services via the internet, either using an HTTP call or a REST API response. Like I said earlier, in terms of data formats, the table storage and the blob storage, they have arbitrary data formats. So it's not rigid. They can take any form of data structure that you provide to them. All right, so the next slide, data platform continuum. So this just gives an insight of how SQL Server has evolved over the years. So before now, in the years back, SQL Server started as an implementation on physical machines, that's physical servers, that whereby companies or organizations have to purchase physical servers into their data center or maybe their server rooms. They also purchase licenses for SQL Server, install on these machines, and configure databases for all of their business applications and the likes. Looking at it from that perspective, it demanded a higher cost of maintenance, a higher cost of purchase, and even higher administration, because they also have to ensure that the servers are maintained. They look at the storage, they look at power, running cost of the servers physically was a whole lot for the organizations. So with time, things evolved. It got to a stage whereby from these physical servers they have on-prem within the organization, they were able to utilize virtualization processes to like create virtual machines within, that's Hyper-V virtual machines within the network or the domain in-house, whereby they have, let's say they have 5 physical servers, but using Hyper-V, they're able to spin up about 10 or maybe 15, depending on their requirements, virtual machines running all on the same 5 physical servers they have in the organization. So that way they are able to reduce cost on licensing. They have more SQL Server instances, but still leveraging the same number of instances, server licenses they purchased originally on the physical servers. So with that helped the businesses. So then businesses began to run a private cloud within their network, within their domain, and they use the Hyper-V virtual machines and their physical machines to run their businesses. And that was interesting. It was nice. It saved them some costs because instead of purchasing more physical servers now, they have been able to create virtual servers within their network and use for their different purposes. So that way it has reduced costs. And also in terms of administration, the cloud, the Hyper-Vs that have been created, they don't necessarily have to pay some extra cost for administration on those VMs, because actually the main administration goes on the physical 5 infrastructures they already have. So as things evolved, we get to see SQL Server in Azure VMs. So when Azure came up, when Microsoft released Azure, there was what they call the virtual machines on Azure. So you can just go to the Azure portal, configure a VM on the portal, and provide that VM as a platform, an infrastructure, sorry, for you, whereby you can host your applications, you can do a whole lot within that VM. So it saves you for the infrastructure you use on the Azure environment. So with that, you can list of SQL Server within that VM. So even if you had licenses for SQL Server you've been running on the on-premises servers you could bring them into the Azure VMs, install on the VMs, and continue your business. So that way, it helps to also reduce the efforts of administration that you need to run, because now you don't necessarily need a DBA to monitor the servers physically. The VMs you have provision on Azure, Microsoft data center covers the administration of this hardware, the software updates, and all of that. You don't necessarily have to worry your head about that. All you need to do is bring in your applications into that VM and get your business running. And at the same time, it helps you to save costs. So Microsoft also went further to bring in infrastructure as a service, whereby you can now have Azure SQL databases directly on the Azure cloud. So you don't even necessarily need to provision a VM on Azure. You can just go ahead and create a SQL database on Azure directly. And once you create that, it creates a backend logical server where Microsoft hosts that database for you. Although you wouldn't have access to manage that server as an infrastructure, because what you are purchasing is just the database. So anything that has to do with the data, the server hosting that server, that DB, Microsoft manages it on your behalf. So it saves you some level of administrative efforts and costing as well. So that's just a walkthrough around what Microsoft have done. So for the next slide, I want to walk us through Azure SQL Database introduction. So SQL Database Service, which is our goal for today, is a cloud relational database that Microsoft has provided as a service that you can actually just purchase from Azure. It is designed for cloud-based applications that require zero or no or little administrative efforts and enterprise-grade capacities. It's perfect for cloud architects and developers that are looking for a programmatic and DBA-like functionalities. So what it's saying here is just that a majority of the things you can actually do with your SQL Server on-prem, all of these things are available for you on the SQL database as a service offering. So looking at it from the perspective of elastic scale and performance, you're able to predict performance levels. You are able to do a programmatic scale out and scaling. So depending on how you're using the service, the database, when your data begins to grow, you can scale up the database storage, you can scale up the data usage. And at the same time, there's also a view within the Azure portal that allows you to look at the metrics of how your database is doing, how are you utilizing it, and how is it growing. All those administrative stuff, you can monitor them from a dashboard on the Azure portal. Now, looking at it from business continuity and data protection perspective, people have these worries that, okay, when I put my data on the cloud, what happens to my data should in case one day I wake up and I'm not able to connect to the cloud? Microsoft has actually done a lot around ensuring that your data is protected. So they have provided things like self-service restore. So within the Azure database offering, you're able to do self-service restore of your databases. From time to time, the service does automatic backups of the database. It takes snapshots of your data from time to time, and this helps to ensure that in case a particular data center is down, you don't lose your data. You're able to fall back to the most recent backup that has been run. So you can just do a restore from that most recent backup back to the status your business was and your data was before the data center went down. So in terms of disaster recovery, there's also what they call the high availability and disaster recovery that ensures that, okay, you are using Azure database, but what's the assurance that in a situation whereby the data center where my database is hosted, possibly maybe an upgrade is going on, or maybe something fails within the server in that data center and it affects the server hosting your database. How are you able to mitigate against all of this? We have the always on availability groups. We have a whole number of disaster recovery approaches that have been provided by Microsoft. And the interesting thing here is that you can actually leverage all what you have on the SQL Server on premises, like the failover cluster instance. You can set it up to for your data on the cloud in on-prem to replicate to Azure SQL DB. So even if you are running an hybrid environment whereby you don't want to put all of your data in the cloud, you could just do a backup or a disaster recovery implementation such that if the physical servers on-prem go down, you have a copy of your data in the cloud. And that way you can easily do a restore from what you have in the cloud back to the on-prem servers when they are back up. At the same time, compliance is enabled such that on the Azure portal, there are levels of compliance that you need to set up to just be sure that your data is safe and your business is not at risk. So looking at it at the angle of how familiar it is to the programmers and the SQL developers, it's nothing so different from the on-premise SQL version, like I mentioned earlier. All programmatic functionalities that you have on the SQL on-premises, you can actually do all of that. You can create procedures, you could write functions, you could create views and all of that on the SQL database instance. It's also possible for you to do a self-managed instance if you do an installation of SQL Server into a virtual machine. So when you do that, you have a control over the machine that is hosting your database. But when you go the database service directly, Azure SQL DB, the data is what you have control over. You don't have a control over the server that hosts your data. At the same time, there's what is called elastic pool. So elastic pools are just more like a container of databases that helps you to ensure that, you manage the number of resources and your costing on Azure. So if you have a situation whereby you know that, this database will be growing over time, you can just group such databases into a pool, and they all share the resources that you have purchased on the Azure environment in terms of space, in terms of your costing. So you don't necessarily have to pay per database. One server will host all of the databases. They will all be in a pool, and as the business grows, as the databases expand, you can easily scale up the pool and scale up resources. All right, so quick contrast between the infrastructure as a service, which is the SQL Server in a virtual machine, and the platform as a service, which is our SQL database. So here we have it that SQL Server in a VM is best for existing applications that require a fast migration to the cloud with minimal changes. So if you already have a solution in-house that you've customized, maybe it's running on a SQL 2016 environment, and you are considering going to cloud, and you know that this application, most of the administrative or configurations that you have done on-prem, you still want to maintain them on the cloud. The best bet for you is to just go SQL Server in a virtual machine. Just get a virtual machine running on Azure, install SQL version 2016 on that same VM, and do a migration of your data from the on-premises into that database inside the VM. Looking at teams that can configure and manage high availability, disaster recovery, and patching for SQL Server. Some provide automated features dynamically to simplify this. On the contrast, if you look at SQL Database on Azure, the new cloud is designed basically for applications that have time constraints in development and marketing. At the same time, you also have teams that need to build in high availability, disaster recovery, and upgrade for their DB. It's also a good one for them. At the same time, when you want to create a customized environment with full administrative rights, it's always good to go for a SQL Server in a VM. Now, in terms of storage space, SQL Server instances have with maximum of about 64 terabytes of storage. They can effectively run within a SQL Server in a virtual machine. But when you have a database that is of about 4 terabytes or more, it's always advisable you just go direct into a SQL instance of a database and not a SQL Server in a VM because of the size of the database. So also looking at resources, you have some IT resources for configuration and management, some provided automated features that dramatically simplify this. So when you have special configurations around your SQL Server implementations, it's always good you use the SQL Server in a VM. But when you don't really have need for that and you just require a database, you can always go for the Azure SQL DB. So now, yeah, you're saying you do not want to employ IT resources for configuring or management of the infrastructure. You just want to focus on the application layer. Then you can easily just leverage Azure SQL DB. Now, in terms of total cost of ownership, SQL Server in a VM helps you to remove CapEx. So that's your capital expenditure. So you don't necessarily have to consider money to purchase a server. You just spin up a VM on Azure, you install the SQL Server instance. You can, in fact, you can leverage the version of your licensing you have on-prem in the VM. It would work. And that way it has saved you cost of purchasing a brand new server or something. On the other hand, SQL Server DB on the cloud, it helps you to avoid CapEx and OpEx. So you're not paying for infrastructure. At the same time, you're not paying for administration or any other thing. So there's no capital expenditure, there's no operational expenditure. In terms of scalability, for the SQL Server in a VM, you're able to scale up to about 343,000 TPS. TPS here means the transaction processing system. So this is just a way of measuring how the database is performing. But on the other hand, for the Azure SQL database, you're able to scale out to thousands of databases, processing terabytes of OLTP transactional data. Okay, looking at business continuity, SQL Server on a VM, on Azure VMs, lets you to set up high availability and disaster recovery for your database's specific needs. Therefore, you can have a system that is highly optimized for your application. At the same time, you can test and run failovers by yourself when needed. Yeah, so this gives you the flexibility of testing around your HA and DR implementations. You want to see, okay, what happens if this particular cluster goes offline? How is my data replicating to the next instance and all of that? But when you're looking at Azure SQL database, although it has a full tolerance for infrastructure capabilities, it also provides automated backups, like I mentioned earlier. So the backups are automatic. You don't have to get a DBA to automate data backups like you have to do on the SQL Server in a VM. Points in time restore is available. There's also the geographical restore and active georeplication of your data. So depending on how you set up the DB, you could do a geographical replication. So if you have created the DB in the East region, you could at the same time do a geo-replication of your data to, say, West US or something, such that if one region is unavailable, you can get your data from the second region. Now, looking at the hybrid cloud benefits, using SQL Server on the Azure VM allows you to run partly in the cloud and partly on premises. A typical example here is when you try to extend your on-premises Active Directory domain to the cloud using an Azure virtual network. So you currently have an in-house AD, but you want to leverage that AD on Azure. You don't want to just fully utilize the Azure Active Directory. You can set up an Azure virtual network and configure it such that your local AD users are able to authenticate via the virtual network and access Azure resources on the other hand, using their local AD directory and domain names. But for the Azure SQL database, your on-premises applications can easily access data within the Azure SQL database. You don't necessarily have to set up the virtual network thing. All you need to do is configure the firewall and ensure that you have set the DB such that external connections, maybe over the RDP access or maybe HTTP access, depending on the configuration policies you have set up within the portal on Azure. Once you do that and you expose the DB to be able to be accessible from an external endpoint, you're able to have access to your data sets on the database. Also, looking at it also supports full SQL Server transactional replication, always on availability groups, integration services, and log shipping to replicate data. So this gives you some more flexibility around approaches to how to implement your HA and DR. So you can either go the always on availability route. You could also try log shipping or database replication. Using the Azure SQL database, it supports SQL Server transactional replication as a subscriber to replicate data. All right. So looking at our usage scenarios here, when is it best to go SQL database managed instance? When is the best time to use the SQL database single or elastic pool? And when is it best to use the SQL Server infrastructure as a service, which is our virtual machine? So here it says that for customers looking to migrate a large number of applications from their on-premises or infrastructure as a service that are self-built, or maybe an independent software vendor has provided for them with little migration efforts, it's always best they just use the SQL managed instance. So the managed instance is not so different from the SQL database service. It's just that with the managed instance, it allows for some flexibility to support your on-premises implementations, and it's relatively easy to migrate from on-prem into a managed instance. So the next point here says using the fully automated data management data migration service in Azure, customers can lift and shift their on-premises SQL Server to a managed instance, which offers compatibility with the version on the on-premise and also complete isolation of customer instances with native VNet support. So what it's just telling us here is that when you already have an architecture designed in-house on-prem and you are trying to migrate everything to Azure, it's always advisable you just go the managed instance route, because with the managed instance approach, you're able to manage the server that is hosting your database, leveraging setups that you currently have within the on-premises architecture. At the same time, if you have a software assurance license, or maybe you are using enterprise editions of your SQL Server, you can exchange your existing licenses for discounted rates on the SQL database managed instance using that's what we call the Azure hybrid use benefits. So once you go on that platform, you can exchange your existing licenses, paying the full rate for the licenses that Microsoft offers. Comes with it for you. So let's look at the SQL database instance itself now, whether it's a single instance of a database or a SQL elastic pool. So this is good for customers that are deploying or developing new software as a service multi-tenant applications, or probably they are intentionally transforming their existing on-premise apps into a software as a service multi-tenant app. So for those that all they need is just a database to host the backend of their application, they really don't want to bother themselves around the data server, the server hosting the database. This is a good approach for them to go. Also, for those that want to create just a single database, you can also go this route. Then if you are considering customizing the operating system or the database server, or you want to do any special setups on this server hosting the SQL instance that hosts your database, your best bet would be to go launch up or spin up a VM on Azure that you have full admin privileges over, and install a SQL Server instance on it. Okay, so when you go to the Azure portal and you try to create a SQL DB or something from the marketplace, this is what you would see. So when you go to the marketplace from the Azure portal, it asks you that, okay, how do you plan to use the service? Do you want to go SQL database? Do you want to go managed instance, or do you want to go SQL virtual machines? So for the SQL databases, either go create a single DB, create an elastic pool, or you create the third one, which is a database server that will host your database. So depending on what you want to do, when we go into the demo, we'll see more of this. So when you try to deploy a database, these are the basic steps that goes with it. So the basic things, it will require a subscription, that's an Azure subscription, a resource group, a managed instance or a server name that will host the database, the database name, then admin login, the password. Okay, what region are you trying to create or deploy this database to? It's also required to provide that information. Also, for the databases on Azure, it will request that you provide an opt-in for pools. Do you want to go Elastic Pool or you do not? Then in terms of the storage and compute for this database, it will require you to provide some information around that, like what size of DB do you want to set up and all of that. The network connectivity here talks about how do you want to access this database. Do you want it to be on a private access level or a public level? Do you want to set up VNet access or firewall rules around it? Then for the managed instance, what kind of connection type do you want to configure for this database? Then additional settings would be the data source for the DB, server collation. Server collation is more centered around the managed instance, whereby you are trying to tell the DB how to treat certain characters or languages. Time zone also applies to the managed instance. Do you want to configure Azure Defender? This is a feature for Azure DB. Do you want to set up tags? So these are little setups you have to do. You might decide to do within the Azure portal just to help you manage your costing. So you could create tags for resources as you create them on Azure, tag them and create like a resource pool or something. Then you can see a costing of by tags that you have created. And then the last part of it will be to review all the settings you've configured and finally create and deploy the service. All right, so let's go into the demo. So for the demo, you will require to go on the Azure portal. Let me just do that. So normally, the Azure portal is portal.azure.com. Yeah, so for those that have not worked on Azure portal before, two things you require. You will require a Microsoft account to create an account on Azure. Then when you now have an account on Azure, you also need to activate a subscription. So what I've done is I just created, if you go to, what's it called now? I think that is azure.microsoft.com. When you go to azure.microsoft.com, for those that want to try Azure for about 12 months, you could just try Azure for free. It gives you about $200 worth of credit to use Azure resources for free. So if you exhaust the $200 credit before the 12 months, then you need to purchase a paid version of a subscription. So once you set it up, it takes you to this portal. And the next thing would be for you to create a resource. So I will just say you search for Azure SQL. So you can see a number of all of the services on Azure SQL. You can see Azure SQL database for MySQL servers, Azure databases. But I want to go through the marketplace route. So just select Azure SQL from the marketplace. Right down that. Azure SQL. Yeah. So here we have the page. So the SQL deployment option is up. So it's asking us, how do you plan to use this service? So for this session, I would just want to create a single database. And let's just look at the attribute of a single database. So it tells us that single databases are a great fit for modern cloud-born applications that need a fully managed DB with predictable performance. If you want to look at the capacities, you can do an hyperscale storage of up to 100 terabytes. So you don't necessarily have to buy a server that has a space of 100 TB on the hard drive. You can just leverage SQL DB on Azure that will give you 1 terabyte worth of storage space. And it gives you serverless compute and it's easy management. So let's just click on create. And my time is far spent. So when you get on this page, it asks you to provide some information, basics, subscription name. So depending on how many subscriptions you have, you could decide to put it in any of them. So you select subscription name, you select a resource group. So resource groups are containers for resources. So I don't have any, so I'll be forced to create a new one. I'll call this Azure Data and AI. Okay. So the next thing now is asking for a database name. So what name do I want to call it? Let me just call it my test Azure SQL DB. Server name, because I don't have any server at the moment to host this DB, I need to create one. I click on create new. Okay, so now it's asking me for a server name. So I'll call this server Azure Data and AI. Okay. Oh, sorry, I missed the spelling here. It's okay. So my server login name, so that's going to be the admin logon to the server. Let me just use my server. Okay. So the password, I will just use password. Let me enter that again. So location, which of the Azure regions do I want my server to be created? So I'll still leave it as East US. Okay, so the next thing now is it's asking me, do I want to use SQL Elastic Pool? Because of our time, I'll just say no. Now the compute and storage, it has given me the default, which is a standard SO. It has 10 DTUs and a storage of 250 gigabytes. So if I want more, I can come to configure and increase it or even reduce it depending on my pockets. So I can reduce this to say about, okay, let me just put it for 5 gig. So you see that as I do that, the costing per month reduces. So now at 5 gig, 10 DTUs, I have $15 estimated for a month. As I increase it, it's supposed to change. If I change the DTs, so you can just configure. So you can see now that I've changed it to a basic tier, maximum of 2 gigs. So it's giving me $4.99 per month. I click on next. So networking is where you configure the access. So now it's saying choose an option for configuring connectivity to your server via a public endpoint or a private endpoint. So I'll just use the public endpoint so I can connect to it over the internet. What kind of connection do I want to set up? So do I want Azure services and resources to access this server? So I would say yes. So if I want to connect to this server from any other Azure resource I will be working on later on, I wouldn't have a problem. So it's also asking add current IP to connect to the same server. I'll say yes, so I can connect from this server to the database. So connection policy, how do you want to configure clients to communicate with your SQL database? Let me just leave it at default, but depending on your organization's requirements, you could come to either go through a proxy if you are within a private cloud, or maybe you have a firewall in-house that will block you. You need to set up some advanced configurations to do that. So next. Okay, so this is the Azure Defender for SQL. So it's asking, do I want to start a free trial or not? So I'll just leave it as not now. Ledger is a preview feature that is not yet fully available. I'll just leave it as default, not configured. Additional settings. Okay, so for data source, it's asking now, do I want to start with a blank database, or do I want to restore a backup, or do I want to just put a sample database in the database? So I will go for a sample database, and it's telling me now that the AdventureWorks LT will be created as a sample database. So collocation was just around language and characters. I'll leave it as default. So the tags, this is not really compulsory. So like I mentioned, it's just to manage your resources and your resource groups and costing. So I'll just leave it blank. Then the final step is my review and create. So this just gives me a summary of all of the configuration I've selected or as used before I click on the create button. So if you go back to the top, okay, so it's trying to validate. All right, so we can monitor the progress here, deployment in progress. So it's deploying. Just wait for the deployment to complete. Still doing it. Okay. So you can see what it has done here. It has created a server, the Azure Data and AI. At the same time, it has created something here. Let me look at the details. It has created a connection policy to the same server. It has created allow all. Okay, let me open this up. Allow Windows Azure. So all Azure IPs, every Azure resource can connect to my server. That's what it's telling us here. Okay, let me go back. Is it done? It's working on the last bit of it. It's creating the database now. All right, so deployment is complete. So we could go to the resource. All right, beautiful. So this is our server name. Just copy this. Come to set server firewall. Let's be sure that configurations are right. So it says deny public access. Let's read. Let's grayed out. Let's be grayed out. All right. So let me just try to connect to the DB from my management studio. So I want to do that on another PC. What's this? To database. So this is SSMS. So I want to connect to my server name. So now I have to use SQL authentication. And remember, I created a user. What was the username I created? My bad. Let me go and check. Where is it? Users group. This is my server. Properties. So this is the admin login, my server ADM. So I'll need this to log in here. Password. I missed the password. Oh, shit.
Can you confirm the user? Go ahead.
All right. Check. Server ADM, yeah. It is. Wow, what's going on? And okay, just a minute. What is this? Into something. It's not its on. Can't it off already?
So Ayo, can we try a password reset at this point?
Yeah, we could. All right, let me go back. So we just need to come back to the portal. So access control. See.
I think we can search for the user under find. I don't know.
Let me see. Reset password, yeah. My case is the problem here. Okay, so let me come back. Okay, so we are connected now. So if I expand databases, I expect to see the sample DB that we created on the portal. Beautiful. So remember, we created the test DB called my test Azure SQL DB. And the data tables should be AdventureWorks. So we can see sample data in the tables. It is bigger. All right. So this is our database server name we created on Azure. This is the database we created. So right now you could create more databases here, do your normal procedures, functions, create schemas and all of that on the DB from the SSMS interface. All right. So I think that brings me to the end of my presentation.
All right. Thank you, Ayobami, for the wonderful section. If you have questions, you can just unmute your mic and then ask your question. But before then, I think I saw in the chat box, Chioma. Was it Chioma or? Okay. That's
Okay, yeah.
I don't know.
Yeah.
Okay,
I raised
Chioma.
my hand.
Okay, we'll take Chioma. Yeah, Chioma.
Ayo, thank you so much. That class was very insightful. I have a question around when we were creating the server. So under the region, I wanted to find out, do we have any this for Africa? Can you hear me? Can you hear me?
Yeah, I lost you at some point, sorry.
Okay. I said while we were creating that our server, you know, under the region section,
I can't hear you again.
we just left it at
okay.
Can you hear me now?
Yeah, you're talking about the region. Yeah.
Yes. Okay, do we have any region in Africa? And why did you just select only US? I think that was East US or something like that. Like you just choose randomly where you want to select or something like that.
Yeah, so your choice of selection would depend around where your data is, because if you choose a region that is far away from you, you'll be having issues with latency. So it's always best you choose a region very close to you. So it's not a must you pick the default. You can just pick something close to your nearest environment. It's my network, bad network.
Okay, thank you very much. I heard you.
All right, thank you for that. In addition, I think during setup, if you're using the test environment, you only have like an option to select from the region option. So that's what it might be. And then, of course, Toby said that in the chat box that there are regions in Africa, not South Africa. Okay, we'll take Chizoba now if you're there.
Michael,
okay,
can I just put more light to what Chioma is asking? I think another thing you need to help us to identify is two data center in Africa. So we have two data center in Africa, in South Africa. Can you hear me now? So why can't we choose those two data center? If you are talking of proximity, do you have any other reason apart from the ramp up traffic that you have through the network when you are going far away? Is there any other reason why you choose that specific data center? Why you're choosing South Africa as one of the centers? I think if I'm correct, that's what Chioma is trying to ask. Or
Okay,
is an additional
to answer
question?
that question, there was no special reason why I choose that.
Can I just add, right? I think for some companies, they are bound by different data protection policies. And internationally, there's the GDPR, there's the PII, and a whole of other data protection policies around the world. So sometimes, so that some customers don't sue some companies, some decide to choose a region that has a protection or a policy that favors them. So there are some that would say, okay, fine, they will only deal with this company if they are guided by the GDPR policy, which is basically prevalent in Europe. So, and from my understanding, apart from South Africa, some other very closer regions are like East Europe, West Europe, so these are regions we can leverage on, but it's also important to understand that some of these regions also are bound by data protection policies.
Okay.
All right.
Okay. In addition.
Okay.
Yeah, I think. Okay. I think in addition to that too, picking region also depend. What Paul said depend on the company. Sometimes the company might be in US, but I think one reason I've seen why people pick East US is because likely from they get updates as fast as other region, but there's no crime picking other regions. Just the main thing is check the latency. There's something on Azure, you can check latency of each region closer to you, and maybe the latency is okay by you or not. So I think checking region, choosing region should be based on latency, protection, and update regularly. So that's the three criteria I will use from my own perspective.
All right, thank you, data champions, for that contribution. So I'll take one more question, if there is any. Okay, is there any other question? Okay, so in the absence of no questions, is Ayodiji? Is Ayodiji there? Okay, it's not there. I just wanted to wish him a happy birthday. And Sheyi, please, can you just any further engagement before we wrap up the section and announce what we'll be doing next week? Sheyi.
We communicate to our platform. There's no any other information from my side except for that Paul has any. But we'll communicate through all our platform for next week program.
Yes, I'll just add that if you do not belong to any one of our groups, please try and join and then follow us on our different platforms. We will drop the link after the class, and there would also be a feedback form link dropped in the community group. Please try and click on the link and fill the feedback form. It helps us improve on our performances on a daily, on a weekly basis. Thank you.
All right, thank you everyone for being part of this section. Ayobami, Adeleke, I want to particularly thank you for delivering on this topic. Thank you so much. We are grateful. All right, so everyone from me, my name is Gbenga Adeleke. Thank you for joining us. So see you again next time. Same location. Bye.
Bye, everyone. Thank you.